In this lesson, we'll talk about the arithmetic of algebraic expressions. So, an algebraic expression is first something that we want to define. So an algebraic expression is made up of constants, which are simply just fixed numbers, and then the concept of a variable, which is a letter that represents an unknown number. So if we want to build an algebraic expression from these, we combine the constants and variable with addition, subtraction, multiplication, division, exponents, and roots. Lots of different things that we can do here. And then once we have an algebraic expression, we can evaluate it by replacing the variables with numbers, and then just do the arithmetic to simplify. So here's a few things about an algebraic expression. So the terms of an algebraic expression are pieces joined by addition or subtraction. Within a term can have individual factors. These are the parts of the term that are joined by multiplication usually, or perhaps division. The coefficient is possibly a constant term in front. Now every one of them has a constant term in front, but it might not be written. If so, it might be 1, or perhaps -1 if it's a minus sign. Besides the coefficient, the remaining part is called the variable factor. So, let's just do some quick practice with these. Let's say the terms are going to be every part that is separated by addition and subtraction. Now this first one looks a little strange, but since this part is inside the parentheses, overall the main term is this big long expression. 4 terms. Alright, then let's look at some factors. So for one of these, here's one factor. Here's another factor. As a matter of fact, you could even maybe split it right here if you wanted to. Here's my different factors. This one really only has one factor. So let me just write factors because that's in green. And then we'll just look at coefficients. So the first term is 24. And that's the whole coefficient. This thing is just a factor. This coefficient is 3. This coefficient is -13. And this coefficient is 1. Finally, the variable factor, if you wish to look at that, the variable factors are just everything else, like the y times the x squared minus 3y. The square root of x is a variable factor. This part doesn't have a variable factor, and for this, xy is the whole thing being the variable factor. So, let's do some quick evaluation. And these are usually pretty straightforward. Sometimes you hear the phrase plug and chug, or maybe just plug it in. Anyway, so to evaluate an expression, we have 3x squared minus 12, and we want to plug in x equals -3. So wherever I see an x, I replace it with -3. And you'll notice I used parentheses here. That's always a good idea to do. And then we just need to use our order of operations carefully. So, exponents first. -3 squared is -3 times -3. That's 9. Then we do multiplication. And finally we do the subtraction. Next example. We're plugging in x equals 3 and y equals -1. Now notice how I just did this one. The negative was in front of the x squared. So order of operations says the square comes before the negative. So I kept it that way. I just put the 3 in parentheses and the negative is still in front. X is 3 and y is -1. I didn't put this 3 in parentheses because that might be a bit redundant. So now let's just do our work. Let's start inside the parentheses. So we've got 3 minus and -1 squared is 1. We did our exponents. Now we'll do the last bit inside the parentheses. 3 minus 1 is 2. Now let's see. We've got exponents next. And then we've got multiplication. And finally, we get the addition. So these are usually pretty straightforward. It's just a matter of, are you still decent at your order of operations? Alright, next let's talk about the properties of real numbers. Now this has got a lot of information on it, but there are a lot of nice properties. We're not going to dig really deep into these, but we are going to use some of them when we're solving equations. So, properties of real numbers. The first property is closure. Simply saying that if you add or multiply two real numbers, you still have a real number. Commutative rule. This is one you use all the time without even realizing it. You can add or multiply in the opposite order. Kind of like 2 plus 3 is the same as 3 plus 2. Associative. You use this one automatically no matter what. Anytime you do three numbers, you can really add them or multiply them in any order that you want. And so this is the idea that you could do the first two in a group and then add the third, or you can do the second two in the group and then add the first. Another one is the identity property. Simply put, if you add or multiply by a special number called the identity, then you get back what you started with. In this case, if you add 0, you get back what you started with, or if you multiply by 1, you get back what you started with. Then we've got the inverse property. The inverse says that for every real number, there exists another real number that when you do the operation, you get the identity back. So for addition, it's the negative number that takes you back to 0. For multiplication, it's the reciprocal that takes you back to 1. But just one quick note, 0 times anything could never be 1. So 0 does not have a multiplicative inverse. And then finally, there's the distributive property, which if I draw this, it will probably look immediately familiar. It's just the idea of taking the number over the parentheses. And then a few more properties, and we'll be using these all the time. This is what we call the addition property of equality. Simply put, you may add the same value to both sides of an equation, and the equation still has the same solutions. So, adding and subtracting falls under this. Add or subtract whatever you want. That's fine. The multiplicative property of equality. If you multiply or divide both sides by a number, your equation still has the same solutions. The only thing is that you can't multiply or divide by 0 on both sides, because that breaks the equation. And then finally, the zero factor property. You use this every time you solve a quadratic equation or something similar to it. If you have a product equal to 0, then you can set each one equal to 0. Let's practice these rules. Determine what property is being used in each statement. So for this first example, we do notice that there are some parentheses floating around in the problem. However, you really only have one factor and another factor switching places. And so this is pretty clearly the commutative property. So, with this being the commutative property, it's nice to specify that this is also the commutative property of multiplication. Next example. We've got the 4x minus 3 minus 4x minus 3, and this might make a little bit more sense if you look at this as minus is instead plus a negative. Then you've got a number plus its opposite, and this is what we call additive inverse. The next example is pretty similar. You've got a 7x, and you've got its reciprocal, 1 over 7x. This is what we call multiplicative inverse. And then the final example, notice we have 3 terms, and the parentheses are simply changing places. This is what we call the associative property. And just like my first example, let me specify that this is the associative property of addition. Let's solve these equations. Now, first off, you guys look straight at this equation and you immediately know what to do. You just subtract 7 from both sides. But why? why do you subtract 7 from both sides? This is because of this addition property of equality. So this addition property of equality is what allows us to add or subtract a value from both sides. It keeps everything balanced. So anyway, we get x equals 5. Next problem. You guys know I just need to divide by 3. And the reason for this is the multiplication property of equality. So you might ask the question of what exactly is going on here with dividing by 3 and yet we call it multiplication? Well, dividing by 3 is the same as multiplying by 1/3, and all division can be phrased as multiplication in that manner. So we get x equals 4 for this problem. Alright, and then for the next one, we can split this into two pieces because of the zero factor property. We get x minus 3 equals 0, or x plus 12 equals 0. Simply add 3 to both sides, and subtract 12 from both sides here and here, and we get x equals 3, or x equals negative 12. And so these are all of our solutions for these equations.